Electrical and mechanical collaboration for board systems design. Is it really an opportunity? Let's talk about that next. Improving collaboration between electrical and mechanical engineers for board system design. Let's get on the same page before we dive into whether or not that's an opportunity. So first off, what's involved? Really what we're talking about here is taking the board layout in ECAD and being able to communicate that to the 3D assembly of the board in the enclosure in the mechanical application. And so why is that needed, and what's changing? Why do we need to improve that? So if you look at lots of companies making the transition from traditional mechanical products to smart connected ones, you're seeing a lot more board systems in those products. I mean, that's part of the transition. But also, you're seeing that there's a trend towards smaller and smaller packaging, unusual shapes for board systems, tighter spaces, more compact, having to wrap around things, maybe be flexible. Multi-board systems, if you have a lot of demand for compute power and processing, signal processing, and you got to figure out, number one, how does it fit into the enclosure? How does the enclosure fit into the surrounding mechanical product? But it's not just about fit. It's also about function. So obviously modern board systems have tremendous thermal issues. I mean, they generate a lot of heat. And if you don't evacuate that heat, you're going to fry or melt your board. So to really conduct a good thermal analysis of your board system, you really do need a 3D model. There are lots of great CFD, computational fluid dynamics tools out there that are integrated into mechanical tools. But to run that analysis, you really need the accurate definition coming over from the electrical side. So that is kind of the second thing. So the first thing is fit. The second thing is thermal simulations and predicting how you're going to evacuate heat out of that tight space. The third one is excitation and other structural types of issues. So if you want to look at, what are the natural frequencies, kind of like a shaker table test, you really need to be able to conduct a simulation digitally long before you're going to take it to the shaker table, because you don't want to find out there that it's not going to work. You want to be able to find it out digitally before you spend money, before you're going to waste time on a respin. So those are the trends that's kind of driving the need for improvement between mechanical engineers and electrical engineers. So is it really an opportunity? So for the longest time, the way that you kind of exchange information between electrical CAD and mechanical CAD is all file-based. So you can send your layout over, it will automatically populate the mechanical assembly, and you can use that in the enclosure assembly. You can see if there's a fit or if you have interferences. You can run simulations on it, all that good stuff. The issue is that most mechanical and electrical engineers wait until the end of development because each of those things are in change. They're work in process. So the board layout will be changing, the enclosure might be changing because of its surroundings, and they will wait because it's a lot of effort to export and then import that layout and get it into mechanical CAD. It's not always obvious what has changed with the board. There hasn't been good kind of change notification and visualization of what has happened to the board, so you can see, okay, I need to check over here as opposed to over here. So that's been the challenge, and what's emerging are a few technologies that let mechanical CAD and electrical CAD synchronize and pair so that changes can be passed almost in an associative manner, so that it's far easier to exchange changes between mechanical and electrical engineers. There's also better change notification and visualization, and then also interactive highlighting is another capability that's emerging. But recognize that it's not just about the technology. There's going to be a process change. So number one, if you want to take advantage of this, the electrical and the mechanical engineer are going to need to work together earlier in the development process. Even during the work in process phase, before things have solidified, before things have stabilized, you can start exchanging back and forth. And that's when actually there's the most flexibility to adapt to change from the other side. And also that's the best time to collaborate together if there are conflicting constraints between the mechanical side and the electrical side. So it's not just about the technology. Don't have the expectation that you're going to be able to install these solutions and that it's going to fix your problem because it requires process change. It requires communication as well between the engineers. So there's an improvement opportunity here. Make no mistake, but don't underestimate the effort that it's going to take to actually implement that change. That's it. Take care and talk soon.